So welcome to the lecture number 37, dear students. Based on similarity. Last time I explained you the properties of area, base and height. Now this time, this is also based on the same things. That 1.1, question number 4. Okay. Now please see here, AP is perpendicular to BC. Correct? And you will also notice one thing, very important thing, that for triangle DBC, try to understand, for triangle DBC, AP is only the height. You will surprise you know how it is. Because you will find it is given AD parallel to BC. If AD is parallel to BC, you will find very important thing that AP is a perpendicular distance between these two parallel lines, AD and BC. So the perpendicular distance between two parallel lines always remain constant. So this is how you will find for triangle DBC, AP is a height, BC is a base. In the same manner, you will find for triangle ABC, this triangle also, AP is height, dropped on base BC. So this is how you will find that for triangle ABC as well as for triangle DBC, height is same, base is same, their areas will be same. Therefore, ratio of their areas is 1:1. So let's see here. Answer is here that in triangle ABC, and triangle DBC have common base BC. Both of them are having common base BC and common height, common or even you can say same height AP. Therefore, area of triangle ABC is equal to area of triangle DBC. Their areas are same. Reason is, as I explained you, BC is a common base, AP is a distance between two parallel lines, and therefore AP is height for triangle ABC as well as for DBC. Therefore, you got this same. Therefore, ratio of area of triangle ABC upon area of triangle DBC is equal to 1:1. Very simple sum that way you will find, but you must have to give description for the same. Now you will find for question number 5. Figure is given over here. So big triangle is given. Supposing if we call it as triangle ABC. After giving this triangle ABC, ABC is a given triangle. Here on AD there is point P. From point P, here you will find PQ is drawn perpendicular. Then this PC is joined together. PC is joined together. As well as AD is also perpendicular drawn over here. AD is also perpendicular drawn. Correct? CZ. Okay, fine. Now, more or less, this is a figure. Page number 6. Okay? This is a figure and page number 6. Now, you will notice in this figure, triangles, many triangles are involved over here. Now there are some questions based on this. First one, area of triangle PQB, find area of triangle PQB upon area of triangle PBC. PBC. Okay, let's see. We all know the theory. What theory we know? That areas of triangles or ratio of the areas of triangles are proportional to the product of base and height. So PQB, please try to understand. PQB, and next to that is PBC. PBC, this triangle, and PBQ, this triangle. Now for these two triangles, you will notice PQ is a height for triangle PBC, as well as PQ is perpendicular drawn on PBQ. BQ is base for what? PBQ. So in this case, I mention over here, since height of triangle PQB and triangle PBC is same, and that is PQ. Therefore, areas of triangle PBC, areas of triangle PBC and triangle PBQ is directly proportional area of triangle PBC and PBQ directly proportional, right? Directly proportional to their corresponding bases. Their corresponding bases. Height is same. PQ is a perpendicular drawn on BQ, as well as PQ is a perpendicular drawn on BC. Therefore, the next step is area of triangle PQB. Area of triangle PQB upon area of triangle PQB and PBC. PBC is equal to. Now it is very important that we have already mentioned that triangle PBQ is having height PQ, triangle PBC is also having this height PQ. The base, now base for PBQ is BQ. Base for PBQ is BQ. As well as for PBC. Now PBC. PBC. What is the base? Base is BC. So BQ upon BC. We have already given the explanation that why their areas are proportional to their corresponding bases. Is height is same, and that is P. Now second one we have to find out is area of triangle PBC. Area of triangle PBC upon area of triangle ABC. Okay, fine. PBC and ABC. Okay. PBC. See here, students. This is a triangle. PBC. Okay. And next to that is ABC. This is a triangle. Now, what is the common for PBC? Base is BC. For PBC, base is BC. For ABC, this is a triangle. And for that also you will find base is same. Okay. So we'll mention here, since triangle PBC and triangle ABC has common base, BC. Please try to understand again. Triangle PBC, base is BC. Triangle ABC, base is BC. So base is same. If base is same, areas are proportional to their corresponding heights. Now height of PBC, therefore, as common base BC, therefore areas will proportional. Areas will proportional to corresponding bases. Very important. Corresponding bases. So we'll find for triangle PBC, triangle ABC, height is BC. Now what is, base is BC, which is common or same. Height of PBC is PQ. Height of PBC is PQ. Height is always perpendicular drawn from the vertex to the base. So you will find that AD is a height. AD is a height. So if base are same, areas will proportional to their corresponding heights. Very important. So we'll get it over here. This question may come for 4 marks. The reason being that there are 4 sub questions are given over there. So each one will carry 1 mark. But very important that you must have to mention reason and entire explanation is expected. You cannot drop any other thing. Okay, fine. So I write a corresponding basis. So area of triangle, second one, I am writing the answer of second one. Therefore, area of triangle PBC, area of triangle PBC upon area of triangle ABC, that is equal to PBC upon ABC. What is the base of PBC? BC. What is the height of PBC? Is PQ upon ABC. What is the height? Height is AD. Height is AD. Fine. Third one is find out area of triangle ABC. Area of triangle ABC upon area of triangle ABC. Area of triangle ADC. Fine. If I look at the figure, then you will find, please try to understand. ABC. This is a triangle ABC. ABC. Fine? Okay. Now what is the height of ABC? Height is A. Now next triangle is what? ADC. Very important. ADC. ADC is a right angle triangle. ADC is a right angle triangle for which AD is a height, as well as for ABC also AD is a height. Heights are same. Areas will be proportional to their corresponding bases. So ABC, since triangle ABC and triangle ADC has same height and same height is AD, therefore areas will proportional. Areas will be proportional to their corresponding bases. Corresponding bases. This explanation is must. You must have to give this explanation. Very, very important. So you will find here area of triangle ABC upon area of triangle ABC. Fine. Now what we have mentioned that corresponding basis Now what is the base? Base of ABC. ABC. Very simple. BC. Base of ADC. ADC. What is the base? Base is DC. So DC upon DC. We must have to give this explanation, which is very important. Now next to that is fourth one. One more question is there for the same figure. Figure will be same. Fourth one. Question number 5. Sub question 4. In fourth one, we have to find out area of triangle ABC. Area of triangle ABC upon area of triangle PQC. Fine, no problem. Okay, please look at the figure. ADC. Okay, ADC. This time ADC. Height is AD, base is DC. Height is AD, base is DC. Fine. PQC. PQC. QC is a base. QC is a base. PQ is a height. In this case, you will notice one thing. Neither height nor base are equal. Base and heights are not equal. Naturally, their areas will be proportional to the product of their base and height. So therefore, you will get for ADC, AD into DC. AD into DC. While for triangle PQC, PQC, this time PQ is height, QC is base. PQ is height and this is base. So here we write areas are proportional. Areas are proportional to the product of base and height. Product of base and height. So dear students, in this exercise, which was totally based on the fact that area always proportional to the product of base and height, as well as you will find in this one question only, sometimes they are given basing, sometimes they are given heighting, but we got the answer only in the last one, that is fourth one. You will find neither base nor heights are equal, therefore area will be proportional to the product of base and height. That's fine. So this is how you will find we finished question number 5, exercise 1.1. Now very important here we are going to study, dear students. This theorem is very important from examination point of view, because very often, or you can say 90%, this theorem has been asked in more or less all examination. This was there in your old syllabus as well as now it is there in the new syllabus. In all syllabuses you will find this theorem is there, which is popularly known as basic proportionality theorem. Now for this theorem, I am going to give you a very clear idea. As far as theorems are concerned, please remember, as far as theorems are concerned, word to word from textbook must be same. You have to write as it is given in the textbook. You are not supposed to make any changes over there if you deserve to get full marks. Then you must have to write all things in detail. Very important. Now this question is asked sometimes state and prove. So if it is come state and prove, naturally statement won't be there. So statement will carry marks. Sometimes they give the statement and then you have to write the proof. So in both the ways it comes. Very important popular theorem which is known as basic proportionality theorem. Basic proportionality theorem. Popularly known as BPT, or we always write in shortcut BPT. Now in this theorem, statement is important. So I'll write the statement over here. That statement is if a line parallel to a side of a triangle, if a line is parallel to a side of a triangle, if a line is parallel to a side of a triangle, intersects the remaining sides, intersects the remaining sides, in two distinct points, then the line divides the sides, sides in the same proportion. Okay. Now you will find in this case, statement is given. We have to write given. We have to write to prove. If you are going to do some construction, you must have to mention that construction also. So I am going to draw figure now first. For drawing figure, you will find first of all triangle is given. Okay. Supposing this figure will carry marks. These all things are going to carry half of marks, and total weightage of the theorem is of 4 marks. Very important, because if you learn this theorem, naturally you will find you can secure your 4 marks. In 4 marks question, there will be 2 questions you have to attempt, and any one of them, if it will be a theorem, it is easy. Okay, fine. So A, B, C is a given triangle. In this given triangle, you will find this is a line L. Okay, now given triangle ABC, line L divides AB and AC in points P and Q. Fine. So you will find this is a line which divides side AB in point P. This AC line L divides side AC in Q. So that is what I have mentioned over here. As well as it is very important, PQ is parallel to BC. What is important? PQ is parallel to BC. Then to prove that, I'll write it as TPT, means to prove that line divides, this line L divides two sides in equal ratio. Now this L has divided AB in the parts AP and PB. This line L has divided the other side AC in parts AQ and QC. So I'll write it as to prove that AP upon PB, that is equal to AQ upon QC. AQ upon QC. Fine. Now we have to do one construction, and in generally we always show the construction with the dotted lines. Okay, so this way I have drawn this construction join Okay, fine. We'll come to know the reason afterwards. So you can say join PC and QB. Construction. Join PC and QB. PC and QB. Fine. So this way we have done construction also. Now let's write the proof. AP upon PB is equal to AQ upon QC. That is what we have to prove. Now for writing proof, please do remember that I am going to consider two triangles which are drawn from P. Right? This concept is little bit difficult to understand. From vertex P, triangle APQ is drawn. Fine. Again I tell you, triangle APQ is drawn from vertex P. Correct. As well as, very important, which triangle is there? Triangle QPC. Please try to understand, dear students. Triangle PQC is also drawn from vertex P. Okay. And we have studied very important property. Property number 3. When two or more than two triangles are drawn from the same vertex, their area is proportional to their corresponding bases. Reason being what? Their heights are same. So you will find for triangle APQ and triangle PQC, both of them are drawn from P, their heights are same. So you will say where heights are shown. Heights are not shown, but it is understood. This is a property. It is understood. Height is not shown anywhere. That is what also I explained you while explaining the property. That height is not mentioned, then also you have to apply this property. So in this case you will find APQ and PQC are drawn from the same vertex P, and therefore their areas will proportional to their corresponding bases, provided their heights are same. Very important. So you will find that area of triangle APQ upon area of triangle PQC, area of triangle PQC, that is equal to heights same, drawn from the same vertex. What is the base? Base of APQ is AQ upon, this is your triangle PQC. What is the base? QC. Why it is the base? Opposite to the vertex. That's why it's base. So AQ upon QC. Right. Here we mention triangles are drawn. From same vertex. Height same. Very important. Height same. Fine. So triangles are drawn from the same vertex, therefore their heights are same. Okay, alright. I'll label this as 1. Now I'm going to find out the triangles drawn from vertex Q. QAP or APQ is one and the same. Try to understand this. QAP or APQ are one and the same. So I'll write here area of triangle APQ upon area of triangle APQ. Now this time I am going to consider it is drawn from where? From vertex. One more triangle is there, right? Which is that QPB, area of triangle QPB. That is equal to same theory, because in first case we use the third property that whenever two or more than two triangles drawn from the same vertex, height same. In the same way, the triangles are drawn from vertex Q, height same. Therefore, their areas are proportional to their corresponding bases AP upon PB. For triangle QAP or PAQ, one and the same. Base is AP upon heights are same. Dear students, heights are same whenever two or more than two triangles are drawn from the same vertex. So triangles are drawn. Triangles are drawn from same vertex. Height same. Very fine. Label it as 2. Now please look at the figure. I have got, if I compare 1 and 2, if I compare these results 1 and 2, what is very important point to recognize? In the numerator we got the same thing. In the numerator we got the same thing, that is area of triangle APQ here. Here also area of triangle APQ. Now the next step, compare their denominators. Compare their denominators. Now area of triangle PQC. PQC. Is that clear? PQC. As well as second one is what? PQB. The second one is P. Okay, now please see here, dear students. What is given? That line L is parallel to BC. Line L is parallel to BC. Now, if I consider this triangle, for example, BPQ. Fine. What is the base of this? Base of this is PQ. Please try to understand. PBQ, base is PQ. CPQ, base is PQ. Base is same. As well as if I claim height is also same. You'll say how height is same? Very simple. For PBQ, height is the distance between these two parallel lines. As well as for CPQ, height is the distance between these two parallel lines. So this distance is same all over. If this distance between the parallel lines is same all over, naturally height same, base same, area is same. So area of triangle PQC is equal to area of triangle QPD. Triangles lie between same parallel lines, that is line L and BC. Line L is parallel to BC. Distance between parallel lines, is same. Distance between parallel lines is same. Therefore, height is same. Height is same. Okay. Common base triangle. Okay, I'll write over here. Triangle BPQ, triangle BPQ and triangle BPQ and CPQ and triangle CPQ are having common base. Common base PQ. Therefore, area of triangle, very important. Therefore, area of triangle PQC, area of triangle PQC is equal to area of triangle QPB, area of triangle QPB. Therefore, supposing if I call it as 1, 2, comparing result 1, 2 and 3. We have to make use of all three results. So in that case you will find when I say result 1, I got numerator same, APQ here, APQ here, right? And I also group area of triangle PQC and area of triangle QPB are also same. So if left hand side of result 1 is same with the left hand side of result 2, naturally we can draw conclusion that right hand side of 1 is equal to right hand side of 2. So here I am raising. Comparing 1, 2 and 3, we get AQ upon QC. AQ upon QC, that is equal to AP upon PB. So this is how you will find, dear students. We have finished very important theorem, basic proportionality theorem. So some steps, some words I must have skipped out. So from that, for avoiding losing of marks, I would like to tell you, please copy the same theorem from your textbook, not this one, the way I have written. My job is only to explain you how these terms have come. But in examination, as far as theorems are concerned, they are going to see very minute things, where you have written all the reasons you have given properly or not, have you drawn the figure properly or not, have you written the construction given to prove that, all these things minutely they are going to check. So from that point of view, it is very important to note that you must copy the same theorem from your textbook. Okay, now let's see here. You will find that this theorem is wrong in this case. Now there is a converse of theorem. Okay, so converse of theorem is also there. Now converse of theorem states that, right? Converse of theorem states that if, try to understand, if any line divides the two sides of triangle, if any line divides the two sides of triangle in equal ratio, then converse states and then that line is parallel to the third side. I repeat again. For example, line L is there, okay, and if it is given AP upon PB is equal to AQ upon QC. If it is given, I said, if it is given, I am stating converse, right? So AP upon PB is equal to AQ upon QC. Then you have to draw conclusion that line L is parallel to BC. Okay, then you have to draw conclusion. What is it? That line L is parallel to BC. But our basic theorem is what? Whenever a line is intersecting two sides of triangle, right? If line is intersecting two sides of triangle in two distinct points and is parallel to the side, then it always divides the sides of triangle in equal ratio. Okay, that's all. Here I finished lecture number 37. I'll be back for lecture number 38. That time I will teach you a very next important theorem, which is called as angle bisector theorem. And there is one more theorem is also there, that property of three parallel lines, okay, on the intercepts made by three parallel lines on transversals. That theorem is also there. I'll explain you both the theorems. So lecture number 38. But this theorem is very important from examination point of view. Again I tell you, please copy the same theorem from your textbook as it is given in the textbook. No changes are allowed at all. Thank you.